Good morning and welcome back to Satisfactory. And yes, we are once again staring at our water recycling loop. I have done some more experimentation and some more tinkering, and this configuration ran for 8 hours last night with half the bauxite coming in. So we are running an input starved, which we know is the condition that causes VIP junctions to saturate, or at least has caused some of my VIP layouts in the past to deadlock. I'm not going to say mechanisms always work or never work. What I'm going to say is what I have been able to do and not been able to do. So we are concentrating today on the water feedback loop or instant scrap, where we input 6 water and we output 5. This differs from the usual example, because the usual example is a case where we have 2 refineries taking fresh water and 1 taking recycled water. So the recycled water is 1/3 of the input. And there's a difference there, which I will show you. Well, I'm not going to show you the experiment because it's several hours long, but I will go over what's happening. So it is my observation that if you have a fluid pipe junction and both of these 2 input lines are full, and this even works if one of them is coming in vertically. If everybody is full and this guy wants water, it will take evenly from both of them, even if one of them is coming from the top. Now, this may only happen when everybody is saturated and we're flowing because of a difference in pressure. Um, I don't know. Test conditions that I had running where my VIP and headlift reset examples deadlocked. Again, I have a test factory here, and I only have enough bauxite to run this at half speed, 1/3 speed, sorry, third speed. So the two blenders on the end are running half speed, and the rest are running quarter speed. So this is kind of the rough condition, the ugly condition for almost all the junctions. And I had to go all the way out to bare bones. Let's ignore all of the fancy knowledge we've gotten about head lift and pressure and so on in favor of something dead dog simple. If all of these guys are full and these guys have pressure and we're drawing water from this pipe, it draws evenly from these 2. So these 6 want a total of 360 per minute when they're running full blast. So that would mean 360. We're drawing 180 from each one of these. Our outputs are producing 300, and I want to consume all 300. So it's not enough. We'll take this, and he's 180. Well, he's going to, we're assuming everything's going to be saturated here because we are providing more water than we are going to need. So 180, it's going to take 90 from each one of these. Well, 90 and 180 is 270. We're still not draining enough. We would still build up 30 per minute in the fluid buffer. So let's do it again. And we did 45 and 45. Well, the 45 and the 90 and the 180 add up to more than 300. So what happened is if this fluid buffer were half full and we were, keeping everybody saturated, we would be slowly draining the fluid buffer. And we would be accepting 45 per minute from here. So no matter how much water we've got in the system, we're still going to be getting 45 fresh water per minute from this. And we know that we need 60 long term. So what's going to happen is this will drain down until one or more of these guys are no longer suitable. And these are on the end of a valve. I wanted to make sure that I wasn't seeing anything funky with water backflowing from here around to there and so on. So this little segment here after the valve, when that guy has no longer got enough water in it because we're running out of recycled water, at that point, we will then pull more water. Now, after 6 or 7 hours of running, I went up to the top and I took away the lifters that were taking out my aluminum casings. This is all completely full of aluminum casings. Train's running around with a full train load, and the train station on the other end is full, and the buffers on the other end are full. And I've just, during this process, I've turned out so many of these aluminum casings. I could probably just delete this entire plant and run the rest of the game without building another casing. But that's not the way you play Satisfaction. At least not the way I play. So I shut us down by basically starving the output. Okay, so we're backload through. Again, the factory stalling is the condition where the VIP junctions in the past have failed me. Now, I think this is just a hypothesis because I haven't tested it. I think my stall was because I failed to do anything with my outputs. I think these outputs all just cycled into the VIP junction. And what happened was the fresh water was not only filling our inputs, but it was also filling up our outputs. And once you've done that, you're dead. But with all of this in place, and we're explicitly pumping our recycled water into the fluid buffer and explicitly pumping from the fluid buffer to maintain maximum pressure here. So no matter how much we have in the fluid buffer, if there's enough for this pump to get its teeth on something, it's going to keep these guys as full as it can. So that maximizes the amount of recycled water we're using. Okay. So to make this explicit, all of the water outputs from all the blenders go into one pipe. That's going to be 300 per minute from these. When I double the size of the factory, I will have a separate recycling loop. I don't like running pipes at their maximum, but there's an even better reason we'll get to in just a moment. So 300 per minute coming down here, which we pump into this fluid buffer. It doesn't need to be a big one because it stays pretty low. This right here is the highest I saw during the test. This is what we ended up with after I shut everything down and all the machines had all their inputs full and all their outputs were drained completely and we're ready to go. So he never got above about 65 or 70, which is cool. These outputs, in theory, these guys could have 50 each on output, and this would be 300. So we have enough of a buffer here that we could accept all of the recycled water. All of these guys could have set up all at once. Then we would need to, we wouldn't have a whole lot more headspace. We'd have another 100 headspace to handle any more output that would happen before we could drain. And at that point, we would be basically running off of recycled water, so that should drain. So I think this particular configuration is perfect. At least I think it should be reliable and robust. So again, all the outputs through a pump into the fluid buffer. Into a pump, so that even if the fluid buffer gets low, we still maintain the level in these pipes. So this guy here is at 65. This water in this pipe is going to slosh up and down. So if we didn't have this pump, these valves wouldn't see a full pipe. With this pump here, these valves all see this pipe nice and full. And they are going to be presenting to here. Now, looking at this particular pipe isn't fair because all of these guys are connected together and water from this pipe can fill. We are going to ignore these little. Also ignore the flow rate on the valves. I have seen comment after comment after comment that the rate display on the valves is not accurate. The people have verified that the valves are doing their job, the flow is happening and doing what it's supposed to do, and the rate display is just wrong. It's fine. You also notice that I did not limit the rate at any point here. We are not counting on using valves to do any rate limiting. This is because if you use the valves to rate limit, actual amount they output won't be at the rate limit unless the input pipe is full. So if you're saying, I've got a pipe and I want to send 120 per minute, and if the pipe is only at the halfway point, you're not going to get your 120. So I do not use valves for rate limiting ever. Let's keep this simple. So this was simple enough I was able to remember it and reconstruct it twice successfully. And the 6-hour test last night was from this instance, which is the second reconstruction, where I tightened everything up and moved the valves so they were really close. The initial test took like a lot more floor space. This is kind of compressed. So again, look at this. We are about 65 cubic meters of water in. I am going to install the lifters here. So we are going to start sinking the end product of the factory. And with our casings now flowing, this is the same factory we've been looking at before. We've got our assemblers making casings. We've got which are tuned to use all of our materials. We've got our assemblers making sheets, which are not overclocked or underclocked, and they will produce sheets when the sheets need to be produced. They're on demand. And when that happens, they will take ingots that would otherwise be turned into casings. The smelters are using the new repaired blueprint, which I worked on over there. I think I didn't upload that recording. I might have. I don't know. In the last recording, did I do this over there? I might have. Anyway, there were some problems with this blueprint, and in fact, I think the original redesign of the blueprint, the first blueprint I put in had the floor raised, and it had the belts going through that gap in the foundation. It was a really clever, compact build, and it was completely out of character for the rest of the factory. So I put them in like this. These guys, once we get cracking again, all of the factories will now be reporting 25% in the first two slices and 50% in the second one. All of them except for these aluminum all-clad sheets, which are going to be at 0. Because we have all the sheets we want. We have three whole containers full of them. We've got 3 depot uploaders running, so we can now freely do. Anyway, I've been vamping for time, waiting for these guys to get a couple of cycles in. And you can see now that our amount of aluminum scrap is being pulled down and our water loop is running. So we are full of water, started out full of water. But the important thing is every time we cycle, our output is drained promptly. So we are able to get back and do another cycle promptly. And I meant to start my timer in the upper left-hand corner when I released this stuff. But let's grumble. Let it pack up again. I'm going to, I know how I can do this. I cut power to the sinks here. What's the easy way to do this? The easy way to do this is I could put a switch in, but put in a power pole. So I can reestablish power by just connecting that power pole. And we're going to let this come to a stop again. Notice that I didn't watch the fluid buffer when we were doing this. That's the other thing I want to do is get down here and watch the fluid buffer as we get started. Gosh, wouldn't it be nice if I could start this down here? Up we are still moving here. Come on. Okay, so these guys are going to have to. You know what? I'm going to do it the old-fashioned way. I'm going to sever the water. I'm going to drain the system to 0, and we're going to watch it start from that condition. It's going to take a moment for this to drain. So while that's draining, I'm going to pause the recording. I'm going to go add some. I've been running my bauxite train further. So I'm going to pause the recording here. I'm going to go add some more onto the end of the bauxite train area, and then I'm going to come back and see. How about I'm going to perch on top of the water tower here, and what we'll do is I will make, once we are completely stalled, I will make the water connection and start the timer. Back, and it's time to do that. And pausing. Hey, welcome back. So I have let the factory run for a bit while I messed around a little more with the trains up there, working out my next plan. The blenders are idle. They're waiting on water. They have hardly any water in them. I have flushed the entire water network. Should be ready to go. Let me get my fingers ready to start the factory and start the stopwatch at roughly the same time. Now just mechanically, the way I'm doing that is I'll set this up all but the last click. I tab over to the stopwatch, and I'm going to start the stopwatch and connect the pipeline. So it'll be a second or two off, maybe. It does take a moment for the water to flow into the systems. Don't worry about it. Original water source is 120 per minute, so it will not, on its own, be able to source the 360 water we need to run at full speed. That won't happen until we start getting recycled water. But because we are dividing everything out, it should wrap up fairly quickly. Now, these are all starting full of bauxite and coal. So initially, they'll start up slow while they don't have water. As the water starts coming in, they will run faster than normal because they have their backlogs of bauxite. But eventually, it'll settle out. And here is what the fluid buffer is doing. I'm going to leave this on screen for a few minutes. Feel free to fast forward ahead past this bit. If I can sit on my hands without messing with it, maybe I'll give it 5 or 10 minutes. So we're 3 minutes in, and y'all have noticed this fluid buffer is sticking around down around its 20 to 25. Give me a mark. That's pretty typical. This test condition is, as I mentioned, running a factory that is input starved for other materials, which has been the problematic case for my water recycling systems. I could basically disconnect 2/3 of the factory from the water loop and run just 2 machines, at which point we would have enough bauxite to run them at full speed. I don't believe it would change anything about this fluid buffer. The acid test will come when we actually have enough bauxite to run the whole. So have some drinkables. If we are running steady state at half capacity, our fill rate will average 150 per minute, and so will our drain rate. And they are actually pretty close. I would wish for those numbers to be smoothed a bit. I'm going to let this go until the 5-minute mark, and then we're going to continue onward with other things. And we can mess around with the bauxite train and look at getting more bauxite in and come back. I will leave the timer going, come back in a while and see how our water loop is behaving. Like I said, this water loop ran in this configuration doing this exact test for 6 or 7 hours last night, so we should be good. Maybe we can finally get away from recording session after session of here's what I'm trying. And yes, there is approximately 10 hours of footage now that I have deleted, which comprises trying the wrong thing or an hour of watching it stay low and then suddenly go up and saturate because something went wrong. So all that footage is stuff I'm not going to be uploading. 5:35. Okay. Let's go do something else for a bit. I believe this is working. And we are short bauxite. We are short a lot of bauxite. So this is our AL aluminum station bauxite drop. And I actually have a train somewhere. I think it's in my pocket at the moment. I've put some entrances on the hypertubes. I still don't know what I'm going to do with my hypertubes. So we are headed up and around it. Mainly this is to gain altitude. Where we're headed is where we want to pick up basically bauxite at this site, and we want to start picking up here. I want to arrange it so that I can head out to the west. There's pure nodes out west that I want to get. And I have brought it up around nice high altitude up there. We have a 4-way intersection, so I can head trains off in 3 different directions from the base. I haven't yet decided whether I'm just going to have one train that goes around all of the bauxite mines and picks it all up. I may start with that and then later add, divide out the mines so that we have a train that goes to these mines, a train that goes to those. I will have to watch and see which trains are coming back full. If I have one train going to all of the bauxite and it can't, it can't fill itself up along the loop after it gets going, or excuse me, if it starts doing cycles around the loop and there's more bauxite at the mines than a train can carry, we'll put in a second train. I'm assuming we can drain the bauxite out of the station. If I'm bringing back more bauxite than we can handle, then I don't need to do anything with the trains because it's delivering enough, independent of whether I'm draining the or not. So here is my 4-way intersection. Very compact. I attempted to set up path signals in there. As per usual rules, we are a left-hand drive. We're coming in, and this is a path signal. And all of them have path signals coming in and block signals going out. I need to make sure that the block heading out is long enough to hold an entire train. So each train clears the intersection before the next train is allowed in. And you're not allowed in unless your path will allow you to exit on the other side. So I do not want trains to stall out in the intersection because I can't go any further. If we had a total gridlock, I want to see trains waiting to get into the intersection because their exit was full. Unfortunately, whole thing, I do not know why. Oh, I wonder, I betcha. Oh, I connect you up. You may have been connected before. You take a look at what happens. I may not have. No, that's still showing these as the same block. Okay, so that's for the path signal. There are definitely two different blocks. I may not understand what path signals are in this game, so I'm just going to change all these to block signals until I do some research. I do not want to mislead anybody. In fact, let's lay out this whole thing again just to make absolutely sure. So we're going to go over what it takes to do this particular. You'll notice a lot of breaks in the rails where I tried to put signals before. I was unable to signal this properly. By properly, I mean so that we can have trains that don't cross, not intersecting each other's paths. I'm going to remove all these block signals. And we're going to remove all the path signals. Like I said, I'll go do research on the difference between blocks and paths. So from any given input, I'm going to want a right turn, which starts here, and a left turn, which starts up here. And I think I'm going to start it. If I start it here, it'll go 1, 2. So that's right. So I want to start it at this seam. Bring this up to the seam. No, I really ought to at this point be using correct path signaling. Let me go check and make sure I understand what the path signals are for. I'm not sure. Well, let's see. Does it do it here? So we're looking at the path signal. Oh, never mind. These inbox. Path signals. Trains can reserve a specific path through it and will only enter the block if their path allows them to fully pass through. Okay, so I should be using path signals for the intersection and block ones after, and maybe paths in the middle of the intersection if they will fit. So if I had a lot more space for this intersection, probably put path signals in. Let's start off putting the block signals on our outputs. So we are left-hand drive in there, and we're coming out here. So we now have our blocks are now colored. We now need our path signals going in. This is still colored. I think because there is a signal in the blueprint, maybe they got initially placed. Oh, because I just placed that. So now we have coming in here, this is a block. It says we cannot enter this block. There's another train on it. And in fact, because this is a path signal, we can't enter it until we can go through another signal into a block. So now let's put in our left turns. There. That in place. This should be the same block as the green, I think. I could be wrong. It really is a different block. That would be cool, because that means our signaling is doing more work than I thought it was doing. Okay, so just the last one that I put down hasn't been. So when you add a train track, it may not be signaling it. This is what I expected to see. So these rails overlap, so they really do need to be in the same block. I don't want a train sitting on this rail while another train tries to go through the rail. That's good. Now, it'd be really cool if I could put a pass signal right there. But that would only work if I also could put a pass signal here and here. That would separate this so that this is one block, this is another block, and this is another block. That would allow us to maybe sneak trains past each other. So can I, in fact, put a signal here? We're going for full deluxe path signaling, full deluxe signaling on this. If you're on the wrong side, you can hit that, and I can put it at exactly the minimum distance. That guy. Now, that should make this a different color from that and that. It is not, possibly because there's not enough clearance. Okay, so this is where I was having problems earlier. Yeah, so we can't actually make this intersection and that Y, those two Ys, we can't make them different colors. So we're going to have to be content with pathing on the way in and blocking on the way out, so we can always get through the whole intersection. What it means is that a train coming through this way and a train coming through that way will be entering the same block, and they can't stop. Sever them. What are the chances that I could, in theory, still have to do the right turns, though? So we're going to be out of luck when we get the right turns in. But I want to see if I understand signals well enough to do this. Stopped in the middle here. If I put a path signal in here, this rail didn't exist, then that and that should be separate paths. Oh, they are. Okay. What's going to break us here is we have to put in the right turns. Okay. And there's really just no way to get the signals in on there. I mean, you could do it, but you have to build a much larger intersection. You have to have space to put a lot more signals in. So there we are. Now, in order to make the parallel trains, so if this track and this track need to be different blocks, you need to be able to draw a line through here and have all of these cut by signals. So if I put a signal here and a signal here, I still have the problem this whole long thing is a Yeah. Um, just have to signal. I wonder, wait a minute. It's not letting me that signal on the left. So here, let me put both those signals in, but it's not letting me do that. I put, it's literally not letting me flip the signal onto the inside. Okay, so yeah, you would need to make this large enough so that you can put signals in, or you make this into some sort of elevated flyover, or you just say you don't turn right, either you go straight or you turn left. Yeah, if we eliminated the possibility of our trains coming up here and going out that way, then this would simplify, but then how would we get there? We would have to go out one of these and turn around and come back. So yeah, it's that right turn across all the lanes of traffic that's causing us the problems. Out that way, there's our bauxite that we are picking up. Currently, we're using that bauxite. So if I put a train station over there and divert all of it to the train station, we would have to shift over immediately to using the train station. So let's see, what else do we have bauxite handy? We've got it off to the right here. Closest bauxite is 280 meters this way. And the distance between this tower and the other tower is 6 of our blueprints. Our blueprints are 5 foundations. And each foundation is 8 meters. So 40 by 6, 200 and something, 240. What did I say that was again? So if we go forward to the next natural power point, be very near the next bauxite. So let's get our lighting power, which is also our hover pack power. Yeah, naughty me, I should have put that one in immediately. What that meant was when I was hovering over here, I was still drawing power from over there. So yeah, we're headed this way. And I don't think we need to go up, and I don't think we can go down. Can I see where the bauxite is? Is that it right there? Yep, that's it right there. So we may have to snake that bauxite out to the side and up into the rail station. We're headed west. We want this line to go a long way to the west. So what I'm going to do is I'm going to, instead of making a junction and putting the whole station so it can go out and back in, I'm going to have the train peel off, go pick up, and come back onto the main line. Do that. Or do I want to arrange it so this pure node, I'm going to arrange it so that pure node can deliver directly. So we're going to have a pure node here. Okay, I'm taking it back. I will go out this far, and then I will do a normal T intersection leading over to a station on the left or maybe on the right. Pick that up. Let's do this. Hot button number 5. And hot button number. So the fact that my power pole is almost absolutely centered above that bauxite, um, some people say, oh yeah, totally planned. Well, in my case, not only is it not totally planned, it's not even particularly helpful. Let's get rid of the trees that are going through my tracks here. Could be problematic. Leave the rest of them. There aren't that many. I'm going to leave this guy. It means that when we're on the hypertube, we'll go right through the middle of the tree, and that's okay. So if that's the bauxite, what direction do I want to bring? Let's see. Good God, a whole herd of those things. I'm glad they are not aggressive. And there's a purple power slug there. Okay, we're going to have some fun clearing this area. I think I'm going to just have my bauxite mine pointing off in the odd direction here, and then deal with moving its raw material output. In fact, I'm not even going to put a foundation down here. Let's see. You are production miner. Point you down the path there. You normally provide 240. If I overclock you completely, that's 600 per minute. That still fits on one belt. We will be dividing you between the three cars. What I'm going to do is each station is going to fill all three cars. We're going to split it three ways. That's going to happen up above. So wherever we are there, that will go out that way and make a curve. So there's going to be our station out that way. Go. In concrete slab. So there's our, going to make our turn in and our turn in, and I guess coming in from the left. So we'll make our turn around, and there'll be our station right there. I am going to put in concrete slabs with power. Shift from blueprint mode, normal mode. Get this darn thing to its edge. Great. Damn you. It's not going to work. So we take this off. Or high foundation in. Now I can connect that like that. I'm going to do another one of these. Trying to connect it to this guy. Oh. And we want main power connected to the slab powder, not the load. The stuff below this is for the lights only, and it will change color depending on the lights. So we don't want to depend on this for our main line out here. We will be making the turn from here. So 1, 2, 3, 1. So we want this to be that way. You need to power connector. The power line from here to come out somewhere here. We'll work it out in a moment. I think this. So, 2, 2, headed that way. But I want this to be the station. If I want to leave the hole open here, now's the time to commit. I have to drag this out further. His belt has to go. Yeah, let's cut this guy and put it. We're pulling into the station. So this is our first cargo station starting. Bye, tree. Okay, let's get the power hooked up so we don't keep losing our cover. He needs to come down here. We're going to connect directly to this center point. If I get all these interconnected successfully, means that if I ever have to delete one of them, others, if they're still adjacent to each other, will still find a path to move their electricity around. That's the whole point to having all these redundant connections. So you can't just put down a cargo. This is actually, I consider this to be a bug. I can't put a freight platform down here and build toward the head. I have to put front down first. So we put placeholders. There's one freight platform, 2 wide, 2 foundations wide, 2 foundations, second platform, 2 for the third, and I need another pair of these. Get the power. Oh, let's put one more in here. tab or I think that's still faster than doing the whole thing manually, and we do have a power line which thinks it's marked for instruction. And to get rid of that, hit F, Control, swipe on a bunch of things, including the thing that was marked, hit Escape, and it will. Here is where our station will finally go. We're pulling into the back of it. It's turned around like that. All that just to get the proper location for the station. The other way we could have done it would have been to bring this one around and bring this one around and then put our head in here, but that would have put us loading from I wanted to load from this side. Great platforms. But and we'll be loading here. And he's nice and close. So we'll bring it out and around and have it up. Let's get the brake platform turned the way we want them. There we go. And now we just need to bring our output around out. And normally I would either here or on this side, I would jog it over a couple to bring it tight. I'm just going to loop it out and around. I'm not going to see. So 3, 1. I know this, I could just lay out the curve, but I know that if I do it this way, I'll always come up with the nice, perfect. Here, we're just going to run this straight over this point, plus however far we want that guy. So we're just bring it just this guy around. So his normal thing for the left turn, come forward another 2, and you're going to go 1, 2, 3 here. But we do need to be on the midpoint. I'm sorry. Come to here. That works. Not exactly the same spacing as we had over there. I may try this spacing on my, may try bringing it to that point on my 4 ways. That's how I build a, just to see if that happens to work better. This goes straight to that. I know I could have made this curve have a wider radius, start it earlier, end it later. Not important. It's not like we've built up a lot of speed coming around that corner that we use of. But for the moment, this is end of the line, but I will be able to continue my rail straight through that way to go pick up normal and pure and pure. I think what I will do is this train station is going to pick up 3 pure nodes. believe a pure node runs 2 of the 6 slices of the factory. See what it does. I am going to call this AL Bauxite load A. You are currently not powered on this end, but I believe you are powered on the other end, so we just have to hook up the tracks. So what I do on these is I always, from the pre-placed railways here, I pull it out by 2, which, as I've noted before, that 2 is the 2 that would bend us up or down if we were going to be going onto a slope. Then we go this way to the midpoint of the run, which is, I am aligning it with the seam in the concrete on the sides here until you're here. That. So now we are connected and make the turn. This turn. Now on other runs, I have placed signals at this midpoint. For this run, I was automatically getting signals every time I put the power towers down. I don't really need to have frequent signals on this line. I can go back later and place them because we still have the seams in the rails. But that should be enough. We should now be able to place our train here. Make sure these guys are set to load. We should be able to start this guy running. Let's see. 9. And place a, well, let's place the electric motive this way first. It's 3 freight cars. 1, 2. We're called the Bauxite train A. I'm going to assume I will have more than one bauxite train. You are going to start by going to bauxite load A. I'm going to leave this as it is because I don't think that the fully loaded or unloaded actually does anything interesting. Or bauxite drop, same thing. Save changes, turn on self-driving. Let's watch it do its thing. Oh, and note, this is actually headed to the loading station first. So it's going to go all the way. It's going to find a place to turn around. And the only place to do that right now is the main base. And then it's going to head to bauxite load A. Those are the only 2 places to turn around right now. So this is just a loop through those 2 stations. The other stuff is all just dead ends. In fact, if I'm just picking up those 3 stations, that first 4x4, first 4-way intersection, could just turn into just a curve. Like I've got these curves. Oh, I came back and put the little diagonal pieces in so the curves aren't too ugly. Still ugly, but they're not too ugly. So we're not stopping here. If there were a train in there, we'd have to stop and let it go. Notice I still have my lights set to red, but the new lights I put in will be white until I change the controls. I think that's a bug. I think the moment you apply power, if there is a lighting controller supplying a control, you should be taking advantage of it. Same as so the same thing that says I have power should also say, oh, and lights on this signal, lights on this circuit are red. See? That light's white. So all of our piers off to the right, so we may never go straight or left here. We may just turn that into a curve. I may leave it in place though, just in case we want to have a train on this line go do something else. So we stop at the loading station and we let the loading cycle once. It has nothing to load, so it probably won't even do the animation. Yeah, I think I'm not going to actually watch the rest of this because I know that it'll be able to find its path. It'll just keep going. Let's put in our input. Organization. We want industrial storages for each one of these. Right in like this. Now, mark 5 belts. As usual, 2 belts, so that despite, even though this will be not accepting input for some fraction of the time, we'll dump from the container into the station as quickly as possible while it does accept it. That's going to be our little dogma. The other thing is that we can only assume that we can have a net throughput half of that. In this case, I have just one miner providing me stuff, so let's put the mark in here. Going to straight mode to make that line nicely. And this is going to go down and pick that up. Okay, well, this is going to be real simple, isn't it? Even going to step this back a ways so kind of obvious what's going on instead of clicking in. Wow, that's like, I'm going to use straight mode. We're just this problem here. Build mode default, we can make that curve. This guy is already set up for 600 per minute. And just connect him like that. I mean, we're right above it almost, so why not, right? So you're actually going to get bauxite for the first time. It's time to go set up the other end. So that's a source of 600 per minute bauxite. How does that compare with our current plans? Let me bring up my editor again. I need to start it up. I have been doing the whole fluid thing for so many hours. I actually just don't even have my editor started yet. Do. Okay, so here are the numbers for the A configuration. Oh, let me move my editor out from under the timer. Not that the timer is important for us anymore because we know our factories are going to keep working. So this is the A production configuration. Doesn't really matter. 750 900 bauxite. So we need a total of 900 bauxite. So this 600 bauxite is enough for the first 4 blenders. And if I merge in the bauxite that I am pulling from the belts up there, we will have enough to run this whole thing. But what I'm going to do is I'm going to keep extending my train. We're going to go get 2 more pure nodes. Like I said, I'm going to start off with 1 train hitting all of them. First step, though, is to plumb this bauxite in station. I'm going to come in over here. It's to be on here. I am going to put it here and here. First question is, do I want to do the full 3 to 3 rebalance? Hmm. 3 to 3 rebalance is a bit of a pain. Show you what it looks like. I had to go vertical. Basically, each container we bring out, it's split 3 ways. I get them on 3. Then I take first lane and I merge them all together. Yeah, let's do this. Needs reworking how I'm guys, that's all right. We've only got 1 load of bauxite in. So we're going to bring containers out to the left, split it. We're going to end up with lanes coming this way, then merge, make the turn at some point. Gosh, that feels like I'm wasting a lot of space. Let's take the containers off to the left to start with. Centered on this line, station as I can and still get a nice right angle out of the, that's where it goes. Put the second one here, or I could move down. See if I put it in line with that one. That for saying. I'm going to bring it over here. I'm going to put my splitters somewhere. Let's see if I doing this for space there. I'm going to try bringing these guys all close in. So each one of these, we're going to be splitting lanes. Okay, I brought it around the corner and did the split. What I should do is put it all. Really should start working. Let's start working from this direction. So here we're going to merge, and we're going to have stuff coming down from above. I'm going to give myself a little space here. Give ourselves a lot of space. Since this is a weird merger, I'm going to give myself a little. And I'm going to put the splitters right here. Splitter. Next splitter is going to have to be left, and the next splitter is going to have to be the right, so we can't stack them on top of each other. I can't put it all the way over here. Oh, why did I put it here? There we go. So he comes over and side comes over and goes into the has to make the leg into here. No, comes over to there, comes over, comes out and makes it into the. I think these two need to be snuck over toward the middle so they can make that. Okay. There. We do need to have holes. Put the holes in to set up our planning. Could put them all the way in. I'm going to back them out by. Like I said, this is a weird merger, weird balancer. So having everything not totally compact is good. Okay, there's that. Our first level, this guy, he just stands out like that. Second level needs to come this line. needs to be to the left a bit. That. Programming from there. Down goer from there. I'm going to all the way out so we can emphasize what's going on here. Top layer. Whole holes per layer. I think that could be centered. I probably could have lowered that by 1. If I do that, these mergers are going to be, hey, let's check that out. Maybe that'll be cool. Maybe it'll make it so we can't set up our inputs. Never mind. And I deleted it soon. You down in front. Now we can. Yeah, I could have brought him down by 1, and now these sleeves would cover the whole. Next time. Now I just need these 3 industrials to output. I think the way I do that industrials right here. We're going to go left and on the center. Get bauxite. You get bauxite. And bauxite. So I'm no longer staggering these. I probably should, but I'm just barely. That's fine. So we now have bauxite deliveries to 3 holes down the places this stuff. Keep the center one, but I have to replace the other. Actually, I'm going to get rid of this whole floor at some point. It's a good portion of it. So, because of the way we are merging, these belts will be balanced. One will stop up and the other two will get half each. So since we're providing 600, that means 300 on each belt. FAR machines will now be running at 100%. These machines will not be running. Right now, they should still be at their low level at 31. They're beginning to ramp. Although these guys should be at 50. Oh, I probably don't have enough coal. I need 600 coal for this. Currently, we don't have a coal train. We have one coal mine up there that's providing. That's it. Well, let's concentrate on bauxite first. We'll go send out for coal, and we'll probably have to send out for sulfur. Coal and sulfur are going to have to come in. What's our ratio there? 600 coal, 300 sulfur. I am thinking that this station over here that we have idled, I will use one train to get both coal and sulfur, and it will do its rounds. What that tells me is now we will be running throttled by how much coal we have. Okay. I think the coal is striped out evenly across all of them. True? Yes, we have two lines of coal down here. And we are providing on one line, overclock it. Go take a look at our coal. See if I overclocked it. I think it would have had to because the total up there is 600 for the half the factory. So if we're running that half the factory at half rate, 300 would be we would need. Here's our pilot coal plant. We can see that its little antenna thingy is glowing bluish, and it is turning out 240. Ooh, oh goodness. But 300 still isn't enough. But anyway, think I'm going to call that a recording. The next step is just like what I just did. It's just going out to get bauxite from further away. We have this pure node claimed. I'm just going to head straight west, and I'm going to pick up. Actually, let's go all the way out to the far one. I'm going to go pick up that pure node next, and we will put in an intersection to go get this one as we go. I'm not going to do that on camera. It's a long, repetitive, one track after another kind of. So when we come back, I will have more bauxite coming in, and we can start nailing down how we're going to do coal and sulfur, which will be our first train that carries two different things. I will see you then.